understandings of services or applications which are going to be helping us to look at connecting to internet. The second bits that we are going to be looking at, obviously, in terms of is what are the benefits of running some of these services as on the cloud. Is this going to be beneficial for the organization? Is it beneficial, in general, to reduce certain costs? And what are the risks associated with it? And then how do we ensure that these applications and hardware, which is run remotely using the server, is actually safe and is able to, when I say safe, it is basically safe enough for it to be having application and data installed on it. And this data and application is then, secure from a point of view of access to users and, for the purposes of transmission or obviously communication. So there are 4 assessment criteria in general, which is what we are looking at in this particular outcome, which is understand cloud-based technologies. And these 4 learning outcomes would be focused on first understanding type of technology, benefits, risks, and how do we look at maintaining security on these technologies so that, if we end up creating and using software as a service or applications, then in such cases, how this would actually be useful in terms of saving costs and obviously speeding up, operations. Most of the bits that we look at, in terms of why we want to install and run some of these applications through the cloud is primarily because of the fact that we want the applications to run faster. We want them to be applicable and installable and accessible from anywhere in the world. We don't want it to be dependent on any particular device. And last but not the least, this also allows the application to be used by different sets of individuals, and that is where the application of some of these and installation of some of these actually on the cloud makes perfect sense. So let's get into a bit of a discussion with some of our PowerPoint slides that we've got and look at this in a bit more detail. So when we do look at, one of the first things which will come to your mind and what we want to be looking at is understanding, what is cloud-based technologies. So this is the key term for today because it's a part of the learning outcome. So when we do talk about cloud-based technologies, the simple definition of this would be to say that these are services or resources. Services could be if you're using the MS Office through the internet, or so resources could be if you're looking at storing data on a remote server like using Dropbox or SharePoint or Google Drive. Then in such cases it would be resources. So resources that you could say could be servers, storage devices, databases which are running on e-commerce website, which have all the data and information related to price, products, and then some part of it is software. So when we do classify cloud-based technology, we refer to services and resources. So services would be applications that you run, and resources would be those set of hardware resources which are going to be useful for us to be able to run these applications. And these together are delivered over the internet. That means they are running on the internet with your screen or your output or your display essentially getting the output rather than you having to install, run, and maintain these physical resources and hardware and infrastructure in the same premises. So cloud-based technologies would refer to services and resources that are delivered over the internet rather than relying on local physical infrastructure and hardware to be able to run those applications. Now, these technologies, typically when I say these, I mean cloud-based technologies enable users and obviously businesses to be able to use and access and share computing power and storage. And sometimes you would also see the word being used, which is on-demand services. So for example, when we look at services like Netflix, Hulu, Amazon Prime, these services which are essentially, providing you plethora of entertainment, including movies, music, and other, I would say applications are available to you on demand. So for example, you decide that I want to watch this particular movie, or if somebody else decides that they want to watch this particular movie, then simultaneously a number of users across the globe could be using and watching the same movie, and that is where it will be called on demand. And this can all be managed remotely. And when we do say that these are manageable remotely, what we are saying is the data is essentially stored in cloud servers, and this is managed through software applications or through service providers, which are basically allowing these applications and physical resources available remotely to be able to run for the purposes of providing these applications to consumers. So essentially, when we do talk about cloud-based technologies, we need to be clear that there are going to be terms which are going to be used, terms which are going to be related to your services and resources, and these technologies in together, when we say services and resources, would then allow users to be able to use any sort of data or service remotely without having to have the physical hardware or physical application installed in the premises. Now, one of the other things that you would also need to look at is why is it that cloud computing has become popular? Now, some of the reasons why cloud computing, say for example, so if I say why cloud-based technologies, and if I narrow the word to computing has become, popular. So we also need to understand that why this has become popular is because of the fact that I use one of the terms called on-demand service. So when these services, when I say services means resources and services are utilizable by a number of people together at the same time, then this becomes an on-demand service. One such examples that I would give you is also of the airline. If you imagine if you're traveling on a holiday and you're going on a long haul flight, you typically have the in-house entertainment system which is installed on your seats. Now you're able to watch. There are a finite number of movies, series, sitcoms and other things available on it. All of you are able to watch the same movie. Now, this is primarily possible because the server which is installed is able to, kind of relay that movie across to a number of terminals. And you might have a different start time. Your friend might have a different start time. Somebody must be watching 1 hour ahead, but you're all able to simultaneously watch that movie. So, the technologies which are cloud-based technologies, they allow these resources and these services to be delivered on demand. That means users can provision these computing capabilities, which would allow the server to essentially serve or run the movie at different intervals at different points in time on different screens. And that is where the advantage of cloud-based technologies comes in. So one of the advantage which I would write is on-demand self-service. Now, other advantages if you have to think of is that you're not restricted to a location. So you're not restricted to a location. So for example, if I use the Mac at home and I have this presentation which I'm updating, one of the advantages of this would be that the same presentation, when I access it in the office or in the college, would still be updated and would be accessible because this particular version of the presentation that I'm using is being updated on the cloud. And essentially, because it is on the cloud, every time I want to access this particular presentation, a new or the most updated copy of that presentation gets downloaded to a local machine from where I'm able to access it using the Microsoft PowerPoint application. Now, other advantages that you can think of would be things like resource pooling. Now, one of the things that you would also realize is that when you have installed infrastructure, on the cloud, that means there are a number of people which would be able to also access those services. So sometimes a good example of this is website servers. Now, a lot of websites currently for small businesses, individuals, and others are hosted on a shared server resource. That means the same server has the storage for a number of clients. It will serve the users browsing the website, from that particular server, and that allows resources pooling to happen. Now, it could also be looked at that as your business grows and obviously you want faster services and more users are coming to your site, then slowly and gradually what the business does is also it moves to a dedicated server. That means that could be a rack server or a server on the rack in the cloud or in the data center where your website would be hosted individually, and that infrastructure and resource in terms of the server and its storage would be exclusive to your company because you're paying for that cost. But if you want to keep costs low and you want to make sure that your resources, you're not deploying too much money on the resources, and in such cases you would primarily be using shared hosting services. So in such cases, resource pooling would provide providers the computing resources to be able to serve multiple users, and that would allow, say for example, multiple websites to be hosted in the same server, and that server would be a shared server. Now, apart from this, there could be lots of other reasons why you would want to, say, for example, have cloud computing based technologies. Now, monitoring of these technologies and resources, physical resources like servers, storage, and other equipment can be done more easily because they're all being managed by a centralized IT team. So monitoring can be done, and charges for those monitoring of the resources can be split across various users because some of these services could be shared, the resources could be pooled, and in such cases, monitoring can also be done anywhere from across the globe as long as you have internet connectivity and the user logins and passwords are available with the users. Now, there could be another advantage, which is scaling, or I would use a word called elasticity. Sometimes what happens is that if you look at the option of scaling your infrastructure, that means I would look at an example like a big company is having a product launch, and the product launch would also mean that once the product launch happens, the company would then have the latest version of software available for users to be able to download. Now, in such cases, the normal traffic or the site traffic which the company gets, assuming is hypothetically 1 million users log into the site every day, but during the course of the launch, and because everybody is eager to try out the new things and new software and applications, the load on the website could increase from 1 million to 3 million users for a couple of days. Now, in such cases, scaling of infrastructure is required to be done. Now, one part could be the company looks at buying physical hardware, servers, storage to be able to use. But after the initial excitement and the rush to download the software dies down, the traffic on the site comes down to about, say, more or less the same, which is what the company has been experiencing. But in such cases, buying that storage and the server infrastructure might be more expensive than probably renting or asking some of the data centers to help scale up that particular capacity for a certain number of days or weeks during the initial days of the product launch. Now, in such cases, scaling, which means expansion, and elasticity means expanding depending on how the resources and the traffic on the site is growing, can be done more easily when you have this service, which is your infrastructure and your service being installed on the cloud, is using cloud computing or is installed on the cloud, because it allows quickly to scale up and scale down depending on how the consumer demand is for your product and services. So there are, apart from these, many other different advantages available, but what we would want to do is broadly classify some of the advantages of why companies end up using cloud computing is because of these main reasons. And why this as a model has become quite important is because, for example, a lot of startups today do not want to invest money in physical infrastructure and hardware. So what they do is they end up starting a service with Google, and Google will provide them storage, would provide them Google Meeting, it will provide them emailing, it will provide them applications like Google Docs, some of the other applications which are required for SDK and stacks in terms of software development, and all such can be done predominantly without investing a single amount of money on hardware or hardware resources. And companies could basically start from a single space, or even from a single office, and that would allow them essentially to start running any of these software and software services. Now, as cloud computing has grown, what we have also seen is that there have been different types of models which have come about, which are basically called the cloud deployment models. Now, these cloud deployment models are quite important, and I would say difficult, not very difficult to understand, but they're quite important, because what we want to be able to do is understand why these models have come about and why they are important. So when we do talk about the different types of models that are now available from a point of view of looking at cloud computing, there is something called public cloud. Now, public cloud is services which are offered over the internet but use third party providers. So when we listen and hear about Amazon Web Services, Google, or Microsoft Azure, these are basically third party cloud services which are basically enterprise solutions, and companies like these provide these solutions to customers which are paying for their services. Now, these could be used for a variety of applications like hosting of websites and running applications like MS Office, or if the company has their own customized software and applications, then they can be run using these cloud-based services, and the applications are installed on these third-party servers. Private cloud could be a company could have its own cloud. So when we talked about network yesterday, and when we talk about WAN, wide area networks, if a company has branch offices in different locations, what you would see is that they would also have some sort of an internal storage. And this internal storage or intranet, as we discussed, would be useful for people to have access to, because it provides usual informations or usual bit of information which is required by employees. One such example that I would give you is an HR software, which is normally installed within the own servers or cloud servers of a particular organization. And that allows access to things like public holidays, holiday calendar, leave calendar, or for example, appraisal systems, certain forms that you might require, like you're going on a holiday, you want to book a holiday, you download a form from the intranet and then send it to your manager for approval. Now, in such cases, this data or these kind of documents are not to be accessed by people outside the organization. So an organization would have its own private cloud. That means within its own network, it would create a secure, server or some sort of a partition or maybe hosting on the server, which would allow some of the company documents to be available. And these documents generally would be available to employees. Similarly, private clouds are also available and formed by government agencies, because they would want certain parts of information to be shared internally with employees. And those are documents or parts and bits and pieces of information which normally are required every time. A simple example of that would be, we have a cloud in the organization, and that cloud has all the assignment briefs, front cover sheets, presentations, everything which teachers need to access. So it's a private cloud. It is not something which is accessible to employees or people outside the organization. Then you have a hybrid cloud, which is some part of the cloud you can allow public access. And a good example of this would be, you have a website, but within the website you have a shared portal, and that portal is only accessible by a certain number of people. Now, website is hosted on a private public server, which means it allows access to browsing the website and information given on the website to members of public or anybody who comes onto the site and wants to get hold of services or products which the company is selling. But at the same time, they would also have maybe a small part of the website which is private, and that would be hosted on a server which is private with permissions and user rights and passwords given. So in such cases, sensitive data related to pricing, inventory, or for example, bill of material cost and other bits related to invoicing, which could be offered on the cloud, maybe finance and administration department would have access to it only, could be a combination of public private cloud, and that would be called hybrid. And then you have a community cloud, shared infrastructure for specific community organizations with common concern. You go to the airport, you go to the universities, you would generally see there's a guest login available. And the reason why they have the guest login available is that they are running all the services more or less open to the members of public. But in some cases, some part of the sharing needs to be done across in order to share resources or applications. And in such cases, they would generally have a provision wherein you'd be required to join a public or for example, a network which would essentially allow you to get access to these services. So in such cases, this would be termed as what is called, community cloud. Now, over the years, one of the things which I would also suggest that you need to now be aware of is what are the different types of service models which are available when we do talk about cloud. Because obviously at some stage, all of this is commercialized. And when we do look at these type of models, we also want to understand what is the, revenue model available, or what is the ways in which companies can actually make money. So when we do talk about these models, we are looking at IaaS, which is basically infrastructure as a service. So a lot of companies, when they form data centers, they can lease these data centers off to big organizations like Facebook, LinkedIn, Microsoft, others. But the infrastructure investment, which is creation of the cloud or data center or the data warehouse, is done by a company. Installation of the hardware is done by the company. They do the investments, but at some stage when they have to sell off some of these investment in terms of space, they would use infrastructure as a service to be passed on to these companies. So when you look at a lot of I would say companies which are creating data centers, they would at some stage start selling the capacity of these data centers to private organizations for them to be able to use on a long-term lease. And in such cases, these companies would be focused on installing the infrastructure, creating the infrastructure, and they would then be leasing that infrastructure in exchange for some revenue. And in such cases, that would be termed as infrastructure as a service. Platform as a service means, you're looking at hardware, software tools which are typically usable by everyone in that data center. Now, to give you an example here, there are some of the things which are called, terminals. Now, if you have these servers and infrastructure installed in a data center, what companies would still need is some sort of a software to manage this remotely. Now, either it could be a Linux based or it could be a Windows based operating system software, which is required as an interface between the data center, which is storing the data, and people who are accessing that data from outside. So in such cases, you would need what are called applications which run as platforms. So when you look at Google, when you look at Heroku, or you look at, for example, let's put it this way, when you look at iPhone or Apple has released an SDK for iPhone for other developers to be able to create applications on that ecosystem. So it releases an SDK, a software development kit, and it also releases a platform called Xnote. And that platform is essentially used by developers and companies essentially to be able to run, simulate, and develop these applications. Now, for this, some companies would charge typically some sort of a cost. So when you look at a platform like Appify, today you, me, anybody can create mobile applications for Windows platform and for Google platform, or I think Windows is more or less out, but if you look at Google Play Store and iPhone iStore or iOS Store, essentially you're able to create applications. Now you don't need to learn coding or learn Cocoa or, for example, Python and things like that, but you have these platforms which will allow you to create these applications without having the programming skills. Now, in such cases, these platforms are allowing you, they are intermediaries between the end customer usage applications and the developer or the company which is creating these applications, but they are somewhere in the middle, and they would allow you to essentially create applications which could run on these platforms like the Google Play Store or the iPhone Store, and they would be termed as platform as a service. Software as a service is basically an end customer platform which will allow you to directly use the application. And direct use of these applications would be that you are able to run the software on the platform straight away as an end customer, and they would include softwares like CRM. You have internet, e-commerce platforms. You have Office or some sort of documentation software, and then you have storage softwares like Dropbox, Bbox, and some of the private players which are essentially offering these as storage solutions, and they provide you an interface. So when you have to get an interface, you log into the control panel of the software, which allows you to get access, and then you're able to access all the resources, create folders, or for example, move data. And in such cases, they would be termed as what is called software as a service. Now, having this basic background allows you to understand that why cloud-based internet technologies have become popular. So we look at advantages or benefits, which could be scalability, cost efficiency. Even one of the main points that I should also cover is, for example, recovery. If you have a physical hardware which goes down in your office, it's very difficult for you to quickly replace the hardware, recover the say for example the applications or data on it, and then make it live again. But if you were hosting it on a cloud-based technology, what it would also built in into the service would be a backup and disaster recovery. That means if your server is to crash, or if your hard drive is to go out, then or crash essentially or get corrupted data, then there are multiple copies of such data which are stored as mirror images, on other servers, which can quickly help restore the availability of such applications to users. So literally the turnaround time or downtime in such cases tends to be very, very low as compared to if you had the physical infrastructure or hardware in your location. So with this understanding, we are able to now get into some of the assessment criteria to understand types of computing technologies, benefits of it, and risks associated with such technologies, and how do we secure data by maintaining, appropriate hardware and checks and balances, which only allow people to get access to that data on the basis of authentication, verification, password access, and allows them access to these applications for the purposes of, running them. So, any questions on this so far?
No,
Okay,
it seems
so
clear. Yeah.
good. So when we do look at some of these, I've covered some parts of it for first assessment criteria, because what we want to be able to look at is differentiate between different types of cloud-based technology, which is given here. So on-demand service, you have broad access, resource pooling, rapid elasticity or scalability, and then obviously monitored or measured service. These are advantages of cloud computing or cloud computing technologies. Types are three different models that we discuss: infrastructure as a service, software as a service, and platform as a service. How they can be deployed, we've covered the deployment models: public cloud, private cloud, hybrid cloud, and obviously community cloud. Now, benefits talk. If we do talk about the benefits, some part of it looks at cost coverage or cost savings. Some look at scalability. Some look at accessibility, because it is accessible from anywhere as long as you have internet. You have business continuity because your data is backed up on different multiple servers, and obviously if one server or one site is to go down, then the other site can be restoring, other site can be brought up essentially to quickly restore data, and thereby the downtime tends to be as low as or as small as possible. Now, there are some challenges also that are associated with usage of cloud-based technologies. These challenges include data security and breaches. Now, couple of things that we've seen over the years that have become public knowledge is that if you look at the Apple iCloud service, in 2012, 2011, 12, the iCloud services were broken into by the hackers, and that led to people's data being left in open. That means photographs, sensitive material was put out in that, and that could be one of the main reasons where you would look at security-based software, and security and access has to be restricted or continuously updated in order to ensure that data does breach or data leak does not happen. Now, one of the main challenges is because you do not have the hardware in your control. If you had the hardware in your control, one of the things that you could do is you could just switch off the server, and if there is no connectivity and no external link to the server, there is no way that somebody could actually steal that data. The only possibility would be that somebody needs to break into your office, physically take the server away, and then they would get access to data. But because some of these facilities and applications are online 24/7, 365 days a year, there are data breaches and data leaks which can happen, and this is because of vulnerabilities on these servers. So one of the clear aspects that you have as challenges associated with cloud-based application and technologies is that data privacy and security is always at risk. So risk of data breaches and loss of control can happen if the password falls into wrong hands, or if hackers can break into the password and get hold of your systems, then they can essentially steal the data which is stored on these servers. Sometimes you look at downtime. Now, downtime and outages can also impact productivity, because when you look at moving your services to cloud based, what you're trying to do is essentially ensure that most of your services are available to customers in real time, right? Real time means you have, whether you decide that I want to access, say, as an example, you look at an airline website An airline website allows you to book tickets online on their website. Now, you decide that, okay, in the middle of the night, that, okay, we are going out on a holiday. And you log into the website, you create a password, and obviously you're able to book tickets, see the flight schedules. You're able to do it almost at any point in time, depending on what your preference is. Now, if this was going back 20 years back or 10 years back when there was no online airline sales available or ticketing available as a system, you had to basically speak to a travel operator. The travel operator will give you the options, and then is when you would book your tickets for your holiday. But because some of these are sometimes available 24/7, we get used to the fact that, okay, they are available in real time, and I can, book the restaurant, or I can book the flight, or I can, you know, transfer money from the bank at any given point in time. Now, if you recall, a couple of days back, Barclays Bank was affected in terms of downtime. So 3 days customers weren't able to use, or 2 or 3 days they were not able to use the Barclays services because their servers were down, or there was something which was down. There was a problem with some of their services. Now, whether there was hacking, whether there was data breach, whether there was hardware fault, we don't know because they didn't explain. But essentially, what we saw was that you couldn't bank, you couldn't transfer money, you couldn't receive or withdraw money from the ATM, or if it was available in only limited places, or limited sources were available to use these services. Now, in such cases, the service outages, or basically this breakdown of service, means that it can impact customers and obviously impact the operation of customers. So, in such cases, if you were to have a server in house, sometimes it might be easier to quickly fix the fault. But because these equipment and resources are only available online or in the cloud, sometimes diagnosis of fault and obviously fixing those faults also becomes a bit difficult, because they need to know what these faults are before you can actually go and fix. If it was a hardware problem, say for example your CPU burned out, or your CPU fan turned off, or the memory got faulty, you could actually go in and replace. But because it happens on the cloud and there is this infrastructure, resources, storage, servers are located in different locations, it is sometimes difficult to isolate the fault, and this isolation of fault actually takes time. And once the fault is known, then only you can go and fix it. Then you have compliance, which is obviously very important, because compliance with regulation is required, and regulations like GDPR and HIPAA are very important, because at the end of the day, these compliances need to be maintained so that the information about the customers is kept safe. Now, HIPAA is essentially another form of information, which is basically health insurance, portability, and accountability. So, a lot of companies, insurance companies, medical companies, pharmaceutical companies have this information in the US, which have the information about the clients, or patients, essentially information. If the records of these information which is stored on the records is stolen, or is there is a data breach, then obviously it leads to patients' information being exposed to companies which can charge more premium, which can essentially refuse service, or they can essentially, as a healthcare provider, decide not to offer insurance or premium to some of the customers because of underlying conditions, or their say for example in some cases their health conditions. So compliance with regulation is important, because the information that you're storing on the cloud, most companies ask you to adhere, and finally agree to some terms and conditions. But if you go in and look and read into those terms and conditions, you would essentially find that these terms and conditions are related to privacy, legal and financial penalties, reputational damage. It could be looking at aspects of administration, technical part of the administration of how your data is stored and recovered. It would give you some idea in terms of what this information is used for, what happens if the information breach, if say for example this information is breached, and what does the organization do in its roles and responsibilities to be able to ensure that the data that you have stored on these servers or on the cloud essentially is kept safe. Then sometimes you also have challenges like vendor lock-in. Now, what is vendor lock-in? This particular means This particular term essentially means that you're dependent on one particular provider simply because in order to shift your services from one provider to the other, it might take a lot of time and resources. So when you do look at getting into a particular vendor for using some of these applications, you enter into what is called some sort of lease, some sort of contracts, level agreements, and sometimes changing these agreements or timelines, or for example, movement from one vendor to the other is restricted because of the fact that it requires proper management and obviously can lead to financial oblique lead to basically financial commitments essentially, because you're signing into a particular service for a certain number of years, which could be a contract. And until the contract is complete, you might not be moving from that provider. If you decide to move from within that contract in the middle of the contract, then you might have to pay some penalties or incur some additional costs, and that could be seen as uh, you know a vendor lock-in strategy. Now, generally speaking, when you look at signing up with Amazon Cloud, services, AWS or Microsoft or Google, they would normally sign you in for a year or 3 years or 5 years. Now, if you were to look at moving platforms, or for example, if the company decides that we are moving from Windows to Microsoft Windows to Apple, then some of these services would also require change. But if you're under a contract, then compatibility issues, resources leading to higher bills or intermediate payouts because you're trying to shift the contract would mean that the company would also end up losing some part of the money because they've decided to move, or move the contract in the middle of the contract when it was signed. Now, there are lots and lots of examples of, I would say, cloud-based services which are coming up, and these are examples that I've listed. So Netflix is one of them, which all of you should be aware of because it is a service. Disney Cloud, you look at Netflix, you look at Amazon Prime. These are all examples of, cloud-based services, but some of them are running specifically on Amazon Web Services servers, and this allows you to enjoy movies or music or associated parts of it, like gaming, for in some platforms, irrespective of which machine or where you are actually using them. So these are some examples of real world applications that you use when we say cloud-based technology or using of different types of cloud-based technologies. Now, you also might be aware that you need to be looking into what could be the emerging trends coming up in cloud-based technologies when we do talk about the future. So one such example is edge computing. Now, edge computing is bringing data processing closer to the source of where the data is generated, consumed, and it reduces latency. That means edge computing is a faster way of how your data can be processed, and there are lots of companies which are working on this. Edge computing and quantum computing is one of them. Microsoft is looking at introducing a new chip which will be looking at using qubits as against bits or data that we are aware of, and qubits are able to store more data and able to do multiple calculations at one point in time. So quantum computing, which is coming in, would be very useful for cloud-based technology solutions, essentially because it will allow multiple applications and calculations to be done at the same point in time, thereby increasing the processing power at which you're able to, crunch data or information. Then you have serverless computing, which is developers deploying code without managing servers. Now, as you know that today we are able to do coding pretty much on the fly. You don't need to install a software on your machine. You are able to, in the earlier days, we used to use simulation software to be able to do coding and compilers to be able to run that code. But nowadays, those compilers and simulation-based software is not required. Compilers and software are installed on the cloud, which allows you to run the code and also test the code and compile the code seamlessly on cloud-based servers. So the servers themselves have this software installed, which allows you to be able to run these applications, test these applications on the servers itself without having to have the software installed locally on your machine. And then you have cloud AI and ML, which is basically machine learning and artificial intelligence stepping in into cloud-based applications. So you look at the launch of Google Gemini, you look at Copilot by Microsoft, you look at ChatGPT. Now, these are applications which are essentially running on the cloud or servers essentially, which will allow you to do and use some of these applications without having the need to be able to code, program, or learn how this is to be done. So prompting, as we say, or language prompting, as we say, is required to be learned for using ChatGPT. The more better you're able to prompt the AI, the better all algorithms it is able to use in the background to be able to fetch your information. So these are advancements which are typically happening, in cloud-based technologies when we do look at, the future in terms of the next 4 or 5 years, which we see coming. Is that okay? Any
Yes.
questions on this?
No.
Okay. Now, some of the benefits briefly we have discussed, but what could be the benefits if we go into detail of cloud-based technologies for both businesses and users? Now, there are these benefits that we've discussed: scalability, accessibility, which means 24/7 access from anywhere in the world. You are looking at, one of the benefits could be automatic updates. Now, if you have the software installed on your server, and you have the software installed on your PC, what typically is the difference? Sometimes you get these Windows updates which need to happen on your PC. But if the Windows operating system is being used on the cloud and you're only accessing it from a terminal or a client, then in such cases, you might not need to apply these automatic updates to your machine, because your machine is actually using the most up-to-date software which is coming directly from the cloud and being used on your terminal or on your client. So when you look at from an IT perspective, IT managers or IT administrators would find it easier to manage hardware and updates to the hardware if the software and hardware part of it can be managed on the cloud. That means the updates or firmware updates or software updates or upgrades to the operating system, if they can be done remotely using the server on the cloud, and only a copy of that gets downloaded to your machine when you're using it. When you shut down, or when you shut down the machine, essentially you are shutting down, and all the application and the updates get stored back onto the server. So this way you have access to the latest, most up-to-date version of the work that you have done anywhere on any machine that you access. At the same time, any updates to those machines can be applied on the cloud, rather than waste a bit of your time on the local machine when they are being installed. So typically in the college, when we have these Windows based machines, we do get updates from time to time, which is either the operating system updates or updates to the system, and you have to apply those updates. We normally end up applying them only in the evening after 7 p.m. or up until 4 a.m. in the morning, so that they are scheduled to happen in a time wherein they are not being used as machines. So in such cases, this could also be an advantage if you're having some of these installed, on the cloud. Now, one of the other major advantages that we are looking at is environmental benefits. Now, with IT proliferation at the highest, what we do see is that everybody has more or less some sort of computer based or IT based equipment at home, whether it's tablets, mobile phones, PCs, laptops, or smart TVs and other type of internet based devices. You have more or less a lot of these devices at home. Now, one of the things is that when cloud-based computing was introduced, it was understood that it is essential today from a point of view of also looking at saving the environment, because some of these devices use, or are manufactured using chemicals or, elements which are predominantly, if they are not recycled or, let's say, I'll use the term, if they are not recycled properly, or if they are not, let's say, before being thrown away, if they are not, let's say, if some of these rare earth metals or minerals which are there in these devices are not taken out, then this can lead to pollution of the environment, especially the water tables. And in such cases, because there's a lot of waste now being created by the use of IT technology, a lot of companies and obviously the applications are being deployed on the cloud, because this would mean there is less dependability on hardware which is required to be produced in order to access these applications. One such example which I'll give you is In general, if you look at why in Europe, the European Parliament has made it mandatory for all mobile operators to work together to produce only one kind of cable for each of the device. So they have standardized on a USB as against any other mini USB as against any other cable. Because if you look at the amount of waste which is being created by discarded telephone, cables which are used as charging cables to mobile phones, because every mobile had a different cable and a different type of an interface. Some of them had IEEE, some of them had mini USB, some of them had so iPhone has a proprietary cable. Some of them have HDMI, mini HDMI, different types of cable. So in order to reduce waste and save the environment, what the Parliament, the European Parliament has done is said, let's standardize the cable across these devices. So every mobile phone is now going to come with mini USB cable, which will be chargeable. So Apple cable would be chargeable and usable across any other device. Any other device's cable would also be able to charge an Apple iPhone. Now, this would basically reduce any sort of environmental waste which is being created by unused or discarded cables. Similarly, when we look at hardware, a lot of this can be saved from going into landfills and waste into the environment by installing or using, I would say, physical hardware, but using it on the cloud. So in such cases, the reduction in the use of hardware would also allow the sustainability to be built in. That means you will have less waste going to the environment, and this could, in the long run, benefit the environment from a point of view of less material from the IT side, which is required to be recycled. So there are a variety of benefits that I've listed down here, which are benefits for business as well as users, and they would generally be looking at covering, for example, the second assessment criteria, which talks about benefits of cloud-based technologies. Now, summary of these benefits, if we have to look at, there are four types: operational efficiency, user convenience, financial savings, and obviously security and reliability. If you have the same standards across, now there are two or three standards across the world right now for platforms. One is Unix, the other is Linux, and the third is Windows in general. And if you look at Apple is mostly designed and created in Unix, but essentially they have their own interface. But if you look at these kind of platforms, so if you have to create applications, you look at as a software developer or as a company. Now, if I was to look at selling my apps and listing my apps on the App Store, I would need to prepare one version which is compatible with Apple. Then I would need to also look at selling my application on Google Play Store. So I'll have to create one version for the Android and Windows, although it is there, but it is very small part in terms of the percentage because Microsoft has done away with the Windows operating system for mobiles. So you generally have these two platforms, but there are others also available like Symbian and your BlackBerry and things. So if a software company was to produce an application and then commercialize it on different platforms, it would need to put more resources in depending on where it is getting its sales from. So some companies decide that, okay, I only want to look at creating an application for Google Play Store or an Apple iOS store, but they would skip other applicants or application platforms like BlackBerry, Symbian, because they are not that many in circulation, and commercially it is not viable for them to create those. So when they have to look at security and reliability of it, their investment would go into the biggest install base where they have in terms of consumers, which could be Android or it could be Apple. But if they have to spend money and resources on securing, if there was a, for example, a vulnerability or a, gap discovered in one of the applications, and they also have that version running on Windows, the priority would be they'll start with Android, then they go to Apple, and then they will go to Windows because the number of users are less. So in such cases, in order to look at security and reliability, companies would invest only in such platforms wherein they would see returns coming in. And those would be some of the summary and benefits that you have to look at, for this assessment criteria. Any questions on this?
No.
Okay, the next one that we talk about is what are the risks associated with cloud-based computing? Now, there are lots of different risks, and we discuss some of these briefly. So, risks that we look at can be related to, data breaches essentially, because you don't have the physical hardware in your control. So because they're installed on a third party platform and they're running from a different location, sometimes there would be risks associated with it, and these risks associated would be related to the data breach. That means breaking in by hackers on unethical practices leading to, access of this data, and this data and access could lead to, consequences in terms of loss of information, or the information falling into the wrong hands, or in some cases, if it was sensitive information and it was stored, then it could be utilized for various other reasons and purposes. So data risk and data breach essentially tends to be the most important risk associated with cloud-based technologies. Now, these risks come in from hacking, cyber attacks, reliance of the, or the stability of the internet connection, the kind of or quality of the hardware which is installed, and sometimes it can be related to what is called account hijacking. Now, they are all more or less similar kind of risks, but slight bit of differentiation in these risks. But more or less, the risk is for data access, data breach, and data privacy. Now, cyber attacks could happen because they are trying to get hold of sensitive data. So sometimes information, for example, which is stored in Pentagon or in some of the other sensitive locations, these data and information is not connected or not connected to the servers outside, because they do not want any sort of access to this information to happen from people who are trying to get unauthorized access to it by breaching, or by not breaching, by hacking into these servers. If you do not have a reliable internet connection, there is an issue there. So, for example, all your data is in the cloud, but your internet connection is not reliable. That means your internet connection breaks. Sometimes, because of bad connectivity or infrastructure, you're not able to access your data, or the data which is stored on the remote server. Then, in such cases, that could also mean you are thinking that, okay, the network is down, or you are thinking that, okay, my connectivity is not good, but at the end of the day, that could have been breached, wherein somebody would have disabled your network access, but at the end of the day, they would have access to the information, and that would mean they would, be able to get the data and do whatever they want to do with it. Now, sometimes this can be seen as an example when you have a website, and if you're hosted on a particular provider, and if the website hosting is not stable, customers are not able to get to your website, place orders, and that could mean not just loss of business, but reputational loss as well. Sometimes you would see hackers would take over the website and install a message that unless this ransom is given, we would not return your website, or we would not return and make your domain functional. So this is also done to look at, getting ransom from customers in some cases, and some cases sensitive information. For example, there are loads of examples on the internet wherein people have stored their photos and, intimate material, and that has been hacked by hackers, and in turn they put it onto the website, which means they're able to sell this off for money or to the highest bidder. But in some cases, court of law, by the time it restricts the circulation and brings down the website, reputational damage has already been done. Now, you could also have malicious programs being installed to monitor activity, and that could mean that these could be software or bots which are installed, which would allow the relay of information to happen when you access it, or sensitive information to be relayed elsewhere without you knowing whether this has been installed or not. And again, those are examples of data breaches, because somebody is illegally trying to get access to that information by essentially breaking into the cloud-based servers, or where the material is stored, and their aim is to get access to that information illegally or without, solid reasons or permissions. So when you look at an example of how data breaches can happen, these would be some of the ways in which the data breaches can happen. Physical breaking into the hardware can also happen. For example, sometimes people break into offices or, in certain places to be able to get hold of data on the server. For example, CCTV coverage. Sometimes it is important, but because it is stored on the local machine or within the same premises, that would mean that somebody has to break into the premise to be able to get hold of that CCTV footage from the machine. But if it is stored on the cloud, there is no way that they can actually, remove that coverage of theft or whatever it is they are doing. And in such cases, it makes it easier to store data on the cloud. But sometimes, if this is to go down, if there's a fire in the data center, or if the server goes down, or if the hard drive crashes, and there are no backups maintained, then in such cases also data loss can happen, and that would be one of the threats of looking at storing data on cloud based systems. Is that okay? Any questions on this? The last assessment criteria is looking at what could be the security measures that we could use to install and make sure that the data stored on cloud-based computing infrastructure is safe. So there could be a series of, things that we could do as a business, as an IT administrator, to secure this data. Now, what are these things? Some of the things that we are aware of. Some of these things tend to be installation of a secure certificate layer, SSL certificate running on the machines or on your website through which this particular service is accessed. Then we could look at encryption. Then we could also look at installing software or applications which would restrict people from getting unauthorized access to that data. Things like two-factor authentication, things like a secure password policy, things like an antivirus software. Now, if you look at networks and servers where data access needs to be given to external people, we could use virtual private networks as an added security. We could also look at running a firewall on the server. We could also ensure that apart from the password, there are levels of permissions required to be able to get access to data. Sometimes you see within the organization, if you log into a PC, it'll ask you for a username and a password for access. But then when you get that login and password, sometimes it'll also say you want user access, you want supervisor access, or you want administrator access. So when you look at such PCs and requirements, you would see that in a simple example that I'll give you here is assuming you join a company and you join as a network administrator in the organization. A couple of days down the line, the organization buys a lot of laptops which are to be distributed to employees because some of them are sales employees and they go onto the field and they need to get access to information from the office. Now, when you do configure policies on these laptops, what you would do is you would install, say, for example, an antivirus software. You would enable the firewall or Windows Defender on the laptops. You would also disable the USB port so that no external drive could be used to install programs on the PC or the laptop. And then you would also install VPN client on it so that if people are outside the office, they are able to access the network of the office using a VPN. Now, what are the additional other things that you could do onto the hardware to ensure that there is no malicious program or bot which can get installed from outside these by the use of these laptops and get into the system or the server infrastructure of the office? Now, a couple of things that you would do is, one, you would, for example, if the employee is outside and you're trying to access the office-based server, one of the things the administrator would install would be a two-factor authentication. So obviously you'll require a username and a password, which would be created and provided to you, a secure username and password. But at the same time, once you log in, it'll still ask you for a two-factor authentication. So a text message might go to your phone, an email might come to your, with some sort of a code might come to your email, and you would be required to put that code in to ensure that it is not in the hands of somebody else. Sometimes you could lose the laptop, you could, leave it somewhere and you might lose it, but somebody tries to log in, they would not have access to your email or your mobile phone. And that would mean that the text message or the email, if they don't have access to, they won't be able to get access to the server or the information from the office. The second thing that they would do as a network administrator would be that you would make sure that the system is up to date. That means all the software updates are on the system. The system is using the most up-to-date version of the operating system and the Internet Explorer or whatever browser they are using. Now, the browser that you install would also have 64-bit or 128-bit encryption on it, which would mean that the browser would detect sites which are vulnerable sites, or browser would disable sites which are not considered which are not conforming or let's say conforming to certain standards, and in such cases, those sites would be blocked. Now, as a system administrator, you would be able to use certain policies to block these sites. For example, in most offices, you would see offices would block certain sites like social media sites because they don't want them to be used in the office. Certain other sites like porn sites are blocked in most of the offices because you don't want the access or staff to be accessing such things with the office PC. You would have sites, peer-to-peer networking sites, which will be blocked, which would require and use excessive resources from within the internet and the infrastructure of the office. If people are trying to download movies or, for example, download songs and things like that, there would be sites which would be blocked on the routers and on this on your switches, which would not allow any sort of malicious softwares to be downloaded and installed on the machine. What are the other things that you would do? As a network administrator, you would also disable some of the policies on the laptop, which would mean the employee could download certain softwares and applications, but will not be able to install them because that requires a system administrator password for the machine or for the hard drive on your machine. Now, in such cases, these policies are essentially done in order to ensure that risks associated with hacking, breach, for example, running of malicious software or programs are disabled so that the hardware can be kept secure. And as IT administrators, you would then have this ability to be able to do that on the machine. And that would be done through what is called user level access or control to the device or the machine. So the laptop might be installed in my name, but the administrator access would require a different username and password to be able to install applications. Now, this would allow you to essentially secure any information which is accessible through that device through to the company server, because you are only allowing client level access, not the server level access or access to the information which is stored on the cloud server. So these are some of the various types of security measures which the company would employ to ensure that the data which is stored in the cloud is kept secure and does not allow access to users who do not have permissions to be able to access that information. And this could be done in a variety of ways, as I've shortlisted and created a small table for it for easy understanding. So some of them are software related, some of them are hardware related, some of them are user access related, and some of them are essentially related to permissions or additional permissions which are required to be able to get access to secure part of that data. Is that okay?
Yeah.
Obviously, as one of the slides, what I've also done is provided a slide which talks about some of the best practices. So within the organization, normally on our side as well, all passwords are reset after 72 days. If there is inactivity on any accounts, the accounts get disabled. Now, these are some of the other features that can be used or configured within the system using softwares which allow security and compliance and obviously risks to be mitigated when we look at discussing data security and obviously data access. So some of them I've listed here that data normally on servers always tends to be encrypted. You have limited number of users who have access to that data. If the access is given, then in any case permission and user level access is given. And in some cases, some part of the data which is using application software is always up to date so that there are no vulnerabilities, no holes or gaps in the software which allow backdoor entry to hackers or programs which can be run from those vulnerabilities. And in most cases nowadays, it has become a standard practice to enable what is called two-factor authentication. And two-factor authentication, either through a password sent on email or a text message, ensures the additional level of security which is required by not allowing people to get access to data if they are not authorized to do so. Is that okay?
Yeah.
Okay, good stuff. So that brings us to the end of today's session, wherein we have covered, three things in particular. If we were to look at summarizing, one is to broadly understand what is cloud-based technologies. We need to understand benefits, we need to understand advantages. We need to also understand disadvantages, which are basically risks in terms of security and compliance, some of the challenges which can be, for using cloud-based technologies, and then also understanding what are the benefits for business, as well as if we have to look at using this for business and commercial purposes, then what are the measures, security measures in particular, that we need to implement to ensure our data is safe on cloud or cloud-based technologies. Is that
Yeah.
okay?
Yeah.
Good stuff. So we'll be looking at obviously, the next session. Let me just quickly look at. So the next session is on Friday, 2 p.m. Because
Yeah.
this next coming week is quite busy for us because of the graduation, which is on the 24th. And after the annual graduation ceremony, I think we'll be looking at, the next session on Friday, which is at 2 p.m. And then
Yeah.
subsequently,
Okay.
after that, we have two other sessions on 28th and 29th, which will hopefully help us complete this unit. So the 25th session will be learning outcome 4. Monday's session next Monday will be learning outcome 5. And then the subsequent session on Tuesday will be the assignment discussion session.
Yeah. Okay. And regarding Unit 2,
Yes.
like, is there a deadline for the assignment submission?
I think it's the same bit which I always say, that you have time to be able to do your assignment. There is no rush. But at the same time, what I would suggest is, while you're fresh with it, it's best to submit within 2 weeks, because the moment you leave it behind, more than 2 weeks, then you'll have to revisit some of the sessions and some of the contents that we've discussed. So my suggestion would be to try and submit, by 30th, because by 30th, this unit will also be complete, and you'll be required to then look at, submitting this assignment as well in a couple of weeks' time.
By the 30th?
30th of April, yeah.
Yeah. Okay.
Okay, no worries. Good stuff. Any other questions, Promise? Any other questions, Clement?
No, please.
Okay, that's great.
No, everything is good.
Good stuff. So what I'll do is I'll make a copy of this recording available to you just after the session on the WhatsApp group, and I will see you now on Friday.
Thank you, Mr. Rahman, very much.
Okay, take care. Enjoy the rest of your day. Bye for now.